Hey everyone, how's it going? In today's video, we'll be discussing about this really interesting dynamic programming problem called dungeon game. And before we proceed further, I just want to give like a kind of a fair warning that this is not a very beginner's problem, and if you don't have a lot of experience with dynamic programming, I would suggest you that you first of all go ahead with the more basic problems such as coin change, knapsack, or minimum path sum and stuff like that, so that you get a little bit more comfortable with the idea of dynamic programming. And this is one of the trickier and harder problems, as it does say in the label on LeetCode that it is a hard problem. So I would not suggest you to just start off straight away with this, and I would suggest you to look at some more basic problems before you start to attempt this one. Otherwise you might end up being confused, right? So with that out of the way, let's just first read the problem statement and understand like what we need to do. So it says here that the demons had captured the princess P and imprisoned her in the bottom right corner of a dungeon. That is, we've been given a 2D dungeon or a 2D grid, and all of these different boxes or the different cells are rooms. And the demons had captured our target, that is the princess, and they have hidden her in the bottom right hand side of the room or of the dungeons, right? Now we have a knight, which is us, on the top left hand side of the grid, on the top left hand side room inside this grid, and we need to find a way through the dungeon to rescue the princess, right? So we just need to navigate our way through this dungeon and reach the princess in the bottom right hand side. Now we're given some constraints here. The constraints include the knight's initial health point is represented by a positive integer. If at any point his health drops below 0 or is 0, he dies immediately. That means at any point we must have the minimum health as 1, because at 0 or below you end up dying, right? Now, to complicate the problem further, each of these rooms is guarded by 3 types of options. That is, the first one is a demon, which we will have to fight, and in that process we'll lose some health. Some other rooms might contain orbs, which will increase our health, which will be positive integers, which will increase our health, and some rooms might just be empty, which will mean that they will not have any effect on our health, right? And now the thing is, we need to find the shortest way that we can reach the princess on the top left hand side by only moving in the rightward or the downward direction in each step, and we need to determine the minimum health that we need to start off with to save the princess, right? So the minimum health that we need to start off with, so that we don't die at inside any of the rooms, our health doesn't drop below 0 in any of the rooms, and we need to start off in that manner, right? So yeah, that is basically the problem statement. And let's start understanding how we might think that we approach this problem, and how usually people would approach this problem, and how I approached this problem when I first saw it. So initially you might think that you can start off from the top left hand side and navigate yourself towards the bottom right hand corner of the room, right? But that is not the correct answer, because you might say that, okay, if I am to enter this first room, there's a demon here which will reduce my health by -2. So what I need to keep in mind is that I enter with an initial health of 3, like minimum an initial health of 3, right? Because when you enter with the minimum health of 3 and you fight the demon, he reduces 2 health points, which leaves you with 1 health point, so that you're still alive. This is the minimum amount of health that you needed to survive this room. But now, if you look at the 2 options where you can go, towards the left, towards the right and towards the bottom, to this room or to this room, you'll see that there is more demons there, and that would mean that you'll end up losing some more health. That would mean that now that you had like 1 health point left, doesn't matter which room you enter, the right one or the down one, you will end up dying, because you did not account for that beforehand. You only accounted for the current room or the previous rooms before this one. So you see the kind of error that is there in this approach, because the initial health to enter a room does not only depend upon the room itself, but depends upon the future rooms that you will see, the rooms that will come after this one, and the demons or the orbs that are there inside them. So this complicates the process a little bit, but still it's not the end of the world, and we have a way to deal with that. So rather than just starting off from the top left hand side, it's always better to, if you see that there's a correlation that is ending up looking at future values, it's better to start off from inside the future. That is, we know that our decision for this room, or our decision for this initial health, will be affected by the future rooms or the rooms that we are going to enter. So why not just start off with the final room that we will end up at and just trace our way back to the initial point, isn't it? So what we need to do is, it's better if we start off from inside this room, say that we need to end up at this room with the minimum possible health, so that we don't waste any extra health points. With the minimum possible health, that will be 1. And then we'll start tracing our way back to the left-hand side, to the top left-hand side, right? So yeah, that is basically how you will be looking at this problem. And before I start coding it out, I think it's better to get a more deeper understanding on how this algorithm will be working. And for that, let's switch on to the whiteboard. So here we are with the whiteboard, and let's start understanding this problem. We know that we are going to start from our target position, which is the final room. And just for the sake of simplicity, I have labeled all of these rooms as 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we'll be starting off in room 9. And we know that we want that once we have dealt with the demon in this room, which is going to reduce 5 of our health points, once we've dealt with him, we want to be left with the minimum possible health that will keep us alive, right? We want to be left with the minimum possible health that will keep us alive, so that we don't waste any health points and we get the actual answer, which is the minimum initial health that you needed to start with to end up at the final position, right? So we don't want to waste any health points. So we say that once we fought with this final demon, we end up with the minimum possible health that will keep us alive, right? So let's say that once we fought with this demon, the target health that we have is going to be 1, because 1 is the minimum possible health that will keep us alive. And what we need to find now, what we need to calculate now, is the initial health that you will enter the dungeon with before this fight, so that this initial health, once you subtract the health points lost during the fight, you are left with what your target value was, right? So you will have an initial health when you enter this dungeon, you will fight the demon, and then you will have this final target health remaining with you, right? So how do you calculate what is the initial health that you need? So it's very simple. It's quite simple. It's just a mathematical formula. Just write the target value minus the number of health points that you're going to lose or maybe gain, because we don't know the number of points that are there in that room essentially. For example, we have -5 here, and whatever that results to is going to be your initial health. In this case, it will be 1 minus -5. That makes up to be 6. This means that if we enter this room 9 with the initial health as 6, after the fight with the demon, we'll be left with the target health that is 1. So 1 here is the target health, and -5 here is the health points lost or gained in current room, right? So yeah, this is how we will be going ahead with this algorithm, and this is how we'll be populating the DP table. Now what I want you to keep in mind is that you do not need to memorize these DP tables for dynamic programming problems. You just need to really internalize and realize this idea of how with each step you're solving a small part of the problem, and how you will move further with the problem and use this current result in the next step. We'll get to it, how we'll be using this result in the next step. And before that, we need to record this so that we don't have to calculate this small calculation again and again. So for that, we'll simply create a new DP table, this table right here, which will record the minimum health needed when entering each dungeon ij. So the number of cells that are there in this dungeon is equal to the same number of cells that we'll have in this grid as well. So for example, we just found out that the minimum health that we'll need to enter the dungeon, the cell number 9 or the dungeon at position 2 is 6, right? So we'll just record this here, right? All right, so I'll just erase this so that we have some space left, right? Now the thing is, to enter this dungeon number 9, the cell number 9, we have two options. We can either enter from the top or from the left hand side, right? So we have these two options, so let's just evaluate both of them. Let's say we enter from the top, right, from cell number 6. Now what the problem here is that you have the target value. The target value is 6, isn't it? You need to, after the fight or maybe gain in health points, you need to end up with the value 6. The target here will be 6, which is this value. Why will it be 6? So that after you are done dealing with this room, you are left with 6 health points. So how will you do that? We'll again use the same formula that we did before, which is basically the target value minus the points gained or lost in this current room, which is 1. This gives us 5. This means that we need to enter this room, the cell number 6, with 5 health points, so that once we are done dealing with it, we end up with 6 health points, which is necessary to enter the next dungeon, right? So if we enter with 5 and you see that there is an orb in this room because it's a positive integer, you add 1 to it and you end up with 6, and now you can go to the next dungeon, right? So this is basically how you will proceed with the rest of the dungeons as well. So we just got the value 5 here. Let's record this so that we don't have to calculate it again and again, which is basically the essence of dynamic programming, right? All right, so with that done, let's look at the other option. This option is going to be a little bit more tricky. So just pay some more attention to this. Now looking at the 8th cell, we see that the current value here is positive 30 and the target value is 6. So if we use the same formula again, we see 6 minus the 6, which is the target value, minus the number of health points gained or lost in the current room, which is 30, equal to minus 24. Now why is that so? This means that this room is providing us with a very high positive value. It is providing us with like a huge cache of health points. And to enter this room, you will need minus 24 health points to basically get the exact 6 health points that we need to enter the final room number 9. Now we know that minus 24 health points is not possible. We cannot possibly enter with minus 24 health points because we cannot have any value equal to or below 0 as our health, because then we will die. So we'll cap this. We'll say that, okay, instead of keeping it minus 24, we'll simply enter with the minimum possible health, which is 1. So if you ever face, and if you ever get the initial health as a negative number, what you need to do is, you need to cap it off. You need to replace that with the minimum possible health, which is 1. And this doesn't create any problems for us. All that will happen is we'll enter the final room with more health than we actually had, the more health than the minimum that was needed. So basically what will happen is, if you enter this room with the health as 1, you will end up getting a total health of 31 and entering the next room, which is totally acceptable, right? So yeah, you will record this value, record the initial health to enter chamber number 8 as 1 in your DP table, right? All right, now you can actually continue off further towards the left, or you can calculate some other value, because it's going to be pretty much the same. But first I would like to deal with a more complicated case which we haven't yet dealt with, and then we can just simply fill out these fill out the rest of the cells in the DP table quite quickly. Right, so the case that we haven't yet covered is what happens when you have two options. What happens when you have two options to go to. For example, in cell number 5, you see you can either go towards the right hand side or towards the downward direction. Now what you need to do here is you need to make a decision towards which direction will I head so that the initial health that I need to enter this room is minimized. I'll say that again. We need to decide in which direction we need to head to. Is it the right direction or the downward direction, so that the initial health required to enter this room is minimized. So let's calculate that. If we end up going towards the right hand side, the initial health required will be 1 minus 10, which is 11, right? Oh, sorry, this is wrong. Apologies. The target value will be 5. So because we needed to enter the 6th chamber with the value 5, right? The initial value that was needed to enter the 6th chamber was 5. So the target value here is 5. As we wrote here 5, we need to end up with the target, which is 5. We'll subtract the current value in the current room, which is minus 10 from this, and we'll end up with 15, right? Similarly, for the other option, which is the room number 8, the target value here, the value that we need to enter this room with is 1, right? We just recorded that. So what you'll do is you write the target value 1 minus the value in the current room, which is minus 10, equal to 11. So you have two options. You can either go towards the right hand side or towards the downward side, right? And you need to choose the one which is allowing you to enter the current room with a lower initial health. Which one is that? It's obviously 11, because 11 is less than 15. So you say that you will end up going into the chamber number 8 because it allows you to enter with a lesser initial health, which is 11. So we'll choose the lesser one and we'll record that in our DP table, right? All right, so that's that. Similarly, you can continue filling this up. For example, if you look at chamber number 7, what you do is you see that you only have one option, that is to go towards the right, and the target here is 1. So 1 minus 10 equal to minus 9, which is a negative value, and we'll cap it off, as we said, to the minimum possible health, which is 1. So I'll just write 1 here, right? Similarly, you can continue filling this up, and by the end of it, it should look something like this: 6, 2, 5, and this will have 7. And you can calculate the other cells in the similar manner. I won't be spending too much time here. And what you will notice is, once you are done filling up this table, and once you reach the first room with the index 0, 0, once you reach that, the value, the initial health required to enter that room will basically be your answer, which is, in this room, you will end up with health. You need to enter this room with health 7, and then you can proceed through all the other rooms depending on the most optimal choices at that time to actually get to the princess with the minimum possible initial health. So just be sure to just work out this entire grid by yourself. The formula is very simple. The target value minus the value in the current cell gives you the initial health that you need to enter that current cell with. And when you have more than one option, when you can go towards the right and the downward direction both, you will choose the option that will give you the minimum, the lesser initial health, right? So this is basically how you will be starting off, and this is how you will be implementing this. So this is it about the algorithm. Now let's start with coding it out. All right, so here we are back in our code editor, and let's start coding up our solution. The first thing we'll do is just simply check the base cases, like the invalid cases, that if the size is equal to 0 or the number of columns is 0, we'll just say that we'll just return 1, which is the minimum possible health. Yeah, and yeah, dungeon dot size equal to 0, and yeah, the number of columns. So this will be dungeons 0 dot size. After that, we will initialize a new array, and we'll say that this will be a new matrix that will hold all our DP values. So we'll create a 2D matrix like so, and we'll call it DP. The size will be basically dungeon.size, and the number of rows will be equal to the number of rows in the dungeon matrix. So it will be like this, dungeon 0.size, and we'll just store the number of rows in a variable as dp.size, and the number of columns as well into something like dp0.size. Right. Now we need to start off with the base case, which will be the bottom rightmost element, which is the target element. So what you need to do is simply write dp rows -1, which will be the last row, and calls -1, which will be the last column, and you'll compute that in the exact same manner that we discussed earlier. In the last column, the target value for the health point after the fight is 1, so we have the target, minus the dungeon value, the value that will be lost or gained in this dungeon. So that is dungeon of rows -1 and calls -1, basically the last dungeon, right? And again, checking for the exception in case the value is not negative, the value in this dungeon is not negative and it's a high value, which will actually end up adding a lot of numbers to our health points. We need to cap it off at the minimum possible value, so that because otherwise, as we saw, that we had the initial health coming up to us as a negative number, and we'd not want that. So we will cap it off at the minimum possible health, which is +1. So we'll do it something like this: dp rows -1 and calls -1 equal to max of dp of rows -1 calls -1, 1. So this will simply just cap that value off for us, and it should be perfectly fine. Right. Now let's start off by iterating through our array, or through our matrix rather, from the bottom right to the top left. So for this, we'll use two for loops. For int row equal to rows -1, and while row is greater than equal to 0, and minus row, and yeah, for int call equal to calls -1, while call is greater than equal to 0, and minus call, and open that up. Now one thing that we need to take care about is just to handle that one exception that we have, which is in case the way that we'll start is by this element, and we've already calculated this element up here, so we don't want to calculate that again. So if row equal to rows -1 and call equal to calls -1, if this is the case, that is if it is the last cell in the whole matrix, we'll just continue, right, like so. And now what you want to do is you want to calculate the amount of health points needed to enter the current cell if you decide to go right or to the left. And we'll store this value in two variables, which will be int hp right equal to what we'll do is we will store, this is basically the health points that will be needed to enter the current dungeon or the current cell if we decided to go to the right. So we need to just take care of one base case as well. In case we are at this final column, then there will be no right element, so we need to handle that. And for the same way for the row as well, if we are at the last row, there will be no row below this, so we need to handle that. So how we'll do that is we'll just check if call equal to calls -1. If that is the case, just set this value as int max so that it never gets selected. Or if it is not the case, if it's some other element, for example, somewhere here or somewhere here, we'll replace this with the dp value of the column to the right, which is call +1, minus the value of the current dungeon, which will be dungeon row and call, right? Similarly, the health points that will be needed to enter the current cell in case we decide to go down will be hp down equal to row equal to rows -1. Again, the base condition or the exception for the last, like just to handle the corner case, int max, and again replace dp of row plus 1 this time, because we're looking at the column below this current column, and the same the row below this row and the same column, minus dungeon of row comma col, right? So this is basically picking up the target value from the dp table for the column towards the right. For example, if you were here at 1, 1, it is looking at 1, 2, right? And this is the target value, and the dungeon value would be somewhere, the dungeon value would be -10, and the target value here would be whatever we have calculated in the dp table, right? Similarly for HP down, in case you were here, the dp row plus 1 call would refer to the corresponding target value in the dp table for this cell, and the dungeon row call would be basically -10, right? Yeah, so that is done. Now we will choose the option which allows us to have the lower health points when entering the current room. So we'll simply write int HP equal to minimum of HP right comma HP down, right? And we will simply assign this value to the current DP. So current DPI, DP row and DP call equal to, now again handling that case, in case the value turns out to be negative, in case the health points turn out to be negative, we'll assign them to the minimum possible value, which is 1. So we'll write something like this, HP max and 1. So in case it turns out to be negative, we'll simply enter the current dungeon with the health points 1, right? Because there's no point entering with a negative value, because that is not possible. Yep. So that is basically the for loop, and return dp 0, 0, which is the first element, the first target, which will have our final answer. So let's just try running this, and it should give us an error. Okay, so a small typo. All right, should be fine now. All right, so it does give us the correct answer. Let's submit that, fingers crossed. Hopefully this ends up getting accepted, and it does, right? So 16 milliseconds, again, runs in 12, runs in 16 milliseconds, depends upon the processor at that time, I guess. So yeah, this is how you do this problem, and the code for this problem will be in the description, and if you want to look at that, just go ahead. It'll be a GitHub gist or a GitHub repo, depending on what the current status of my GitHub is. And yeah, so this is basically it for this video. If you learned something new and liked the video, just hit the like button and subscribe for more programming tutorials, and I'll see you next time.